Hello everyone. Welcome to this tutorial. Bit late, but you know, we'll get it done. Uh don't know why Smart Screen was protecting my PC. All right. So, big changes in this. Apologies, my dog may be in the background for this video. Big changes for this week. I added 4 new files. They are empty. We are filling them out. Um, and then we need to make some changes in main, and that is it. That is all that we need to do. As well as we got 3 shaders to edit. Let's open those up now. All right. I've done my best to compress this content by, including the files by default in the project. Um, but yeah. For anyone that's wondering or wanting an explanation for why this is so late, there's a lot of scrapped content for this tutorial. Kind of. Not just that, but I'm having, you know, personal stuff go on. Specifically, I have a broken tooth, and it's causing a lot of pain. And so, um, in the future weeks leading up to my surgery, which is on the 25th, there may be delayed tutorials or things like that. And I apologize for any interruptions that may cause. I'm doing my best to get it dealt with as soon as possible. Now let's get into it. Now open up main. And the 4 created files. Okay. So the G buffer, it is a buffer where you draw everything out and don't do any of the lighting calculations. Instead, you calculate it later. Hence, deferred rendering. You defer the lighting until the end. Yeah. In here we've got a frame buffer and we've got a shader pass through. Window height, window width. And yeah. And so let's get into it. Add color targets to G buffer. So, add color target. RGBA 8. So this is our albedo buffer. Needs all channels. Oh. This is our normals buffer. Does not need alpha. So this is our specular buffer, and technically it only needs one channel. But it doesn't look right when it's just one channel, and you'll see what I mean later. So one important note, you can obtain the positional data using your depth buffer. There's, a calculation that you can do. But here, we're going to use position buffer. And this, as you can see, is a big buffer. It has 32 bits of color depth in each channel. Now we add a depth buffer, just so we have it. And now if you have a resource manager, you wouldn't have to, recreate this shader. This is just an exact duplicate of a shader that we already have. But we don't have a resource manager in here. So what we are going to do is just create the shader again, because it's not really that expensive, because it happens before runtime, so it won't slow down your game during runtime. It'll just slow down your loading time. And then shell fragment shader. And then never forget to do this. A lot of issues that I've seen just have to do with link not being called. Fine. Fine. So you notice over here, we have an enum for targets. So 0 is albedo, 1 is normal, 2 is specular, 3 is position. And you'll notice that this corresponds to this. So what we can do here is, I accidentally started a build. That's going to fail anyways. Sorry, I pressed F5 by accident. G buffer, and then target, veto, slot 0. One, 2. Great. There you go. And then clear is just and then unbind, and then we can just write 1, 2, 3. Pass through dot bind. Oh. So we're gonna do a thing called GL viewport. Any of you that are doing multiplayer, like split screen games, will know a bunch about this, hopefully. But the idea is just we are essentially splitting up the screen into pieces. Draw the albedo in the top left. Target normal. Draw specular. You know what I forgot to do? There we go. Everyone zoomed in. Gonna just quickly go back through all the code that I've written so far. You can pause and copy. And last but not least, here we go. Now that we're done that, we should go to main. And we should actually create our G-buffer shader. File. And then shader slash gbuffer pass frag. And then link. Now the biggest thing that we want to do is we actually have to make it so all of our materials now use a form of a G-buffer shader. So if you have any special shaders, currently I don't have any special shaders applying, that are applying any cool effects to a specific object, you have to write a G-buffer version. Yeah. Next up, one big thing that I've already changed is I have already made it so G-buffer and illumination buffers will resize by themselves. Because we've done enough of that, in other tutorials. Oh, I never created a G-buffer. There we go. G-buffer equals and then go down here, G-buffer here. Now the biggest thing that we're going to need to do first, we can't be drawing to the basic buffer first anymore. Then we just one other thing you'll notice is that means our shadows won't work anymore because our shadow shader isn't in here. We'll fix that later, but for now, we're gonna comment these out, and we're gonna do buffer, draw buffers to screen. Now, we need to write our gbuffer pass. So it's going to be identical, almost, for the data coming in. Specular. Warm float. Texture mix. So this is the big thing. We have multiple color targets. So, just as we do in the vertex shader, we can send data out to multiple outputs. And from there, we just load in our textures. Out colors, extra color. Normals come in a -1 to 1 range. But we want them to be in a 0 to 1 so that they're a color. So we convert. Equals normalize times half plus 0.5. And this converts something from a -1 to 1 range to a 0 to 1 range. out specs. I will. Actually, don't know how to. There we go. Just so everybody can see it. Actually, didn't even realize there was a zoom in function. Have never used it. Then we just literally throw the in pause into the out pause. And now we have a gbuffer pass frag. So what we can do, drawing our buffers. Oh, a set weak starter as the startup project. Wait. And you look. We now have 4 separate buffers of information. Now you notice one thing. Do you see these colors? The skybox is going to mess with those. So what we actually want to do is number 1. Oh wait, I scrolled past it. See this? This is our clear color. I set it to white. So the big thing we want to do right now is keep everything with our skybox, because we're going to make the skybox work later. But for right now, we just don't want it to render. So we comment out the render component. Now it's all white. This means when we read everything in, these will be 1s. And because of the way that we have set the clear color, the important thing here is that they will have an alpha of 30%. Now this doesn't actually affect how much of the screen it clears at all. What this does do is mean that I can read a 0.3 from this on my render texture now, whereas these are all opaque. And that's important for lighting. I'm going to comment that out. Now, the next thing, The next thing that we need to do, we're about halfway into the tutorial now, is write our illumination buffer. And now, all that I have set up in this illumination buffer, and we will be setting up for this tutorial, is directional lighting, and we'll be getting shadows to work again. So, this is the buffer where we combine everything. One big thing that you'll notice, this is a post effect. Only I've made it so the typical apply effect does not work. Doesn't do anything. Instead, you need to pass it a G buffer. Now, the reason why I made it a post effect is so that after you can still apply your regular post-processing effects to it. Geo. And then now we're going to load in directional G buffer shader. You'll notice we're using the pass-through shader because now this is all on a frame buffer. And you'll see this is our file right here. Shaders. Index. Now, one big thing is that you won't have how do I explain this? You won't have a ambient call in every single time you call your directional shader. You don't want that. Instead, we do it separately in its own thing where we composite the shaders afterwards. So this ambient shader does the job of compositing as well as everything else. Buffer, ambient, right. And then, oh, a shader index link. And now we also have a sun buffer in here because we're still using uniform buffers. And then directional light. And then enabled send data. But technically, I have it set up so that you can disable the sun. Let's say you're inside. You obviously don't want a sun. Now, granted, the majority of you, I don't think many of you are going to use this, obviously. But hopefully the idea of it gives you ideas for what to do, how to implement your stuff. And then we obviously still have to call post effect init. And we're going to just start from the bottom. So sun enabled equals enabled. And then sun dot light direction equals light direction. And sun equals new sun. Ham pause equals ham pause. These are both things that you need for the cam position, for lighting, and then light space view projection is for shadows. You'll see what this does later, but for right now, it just draws the second buffer, which is where you accumulate all your light. And then it just draws it to the screen. Right. And his last function. So if sun enabled, shaders, lights, directional, bind, and then you So we're gonna update the sun buffer just in case the data changed. Because we're doing buffer sub data, it's really not that expensive. And then find lighting. And then so we do buffers 1, render to full screen quad, gbuffer.unbind lighting. We don't want the uniform buffer anymore. And then unbind the shader. And now we need to do shader. You'll notice that directional light also includes ambient information. So we're gonna, no reason to update the data. We just updated it. What we should do is move this outside of that if statement so that it always gets updated. This way, no repeat code. And we still need to bind the lighting for specific portions of this. And then we're going to bind color as texture. I'm going to put that in slot 4 because slots 0 through 3 are taken. And then we're going to do something interesting. We're going to bind the buffer that we're writing to into slot 5. And you'll see why once we write that shader. And then some buffer unbind. And that's all. Now we need to do a little bit of setup in main, and then we can write our shaders and we'll be done. So the very first thing that I want to do is we're going to add toggles that will let us draw these buffers that we're making along the way. This will make it much easier to debug if you ever run into issues. Add illumination buffer. Now we're gonna actually switch this out with dot get sunref. And right under game object, illumination buffer, object in place, init, we go. Now we want to go down here to our keys. All right, Control C, Control V, Control C, Control V. And then make this F1, this F2. Literally just right. And now you've written a toggle. And then make it draw equals not. Done, you've made 2 toggles. Technically you could also make this imgui buttons. But and then we gotta make sure to clear it. Very important that we clear it. And you see this where we're calling on the sun. I want to replace this with illumination buffer, get sunref. Another thing that we need to do actually, delete all of this. Back to where we were. So, set shadow stuff. And we got to make sure to update the light space view projection every frame. And then we also got to make sure we get cam pause. Set cam pause. If you're wondering where I got this from, go into render VAO, or sorry, setup shader for frame, just here. It's the exact same code. So now we've updated the cam pause and everything. We are drawing to our G buffer. And so what we want to do now is, remember how I said that we were going to have an issue with our skybox? Well, we're not. We're going to preempt it. So we already have all of our skybox stuff. If you're wondering why skybox is accessible, I removed the curly braces that were surrounding this and commented out this. Oh, don't forget to remove that. And then backend handler, skybox, view, projection. Skybox matte. Skybox set form. And Skybox unbind. Mesh. And then now here's where we use our shadow buffer. And remember how we made illumination buffer except G buffer? There we go. Combine texture, heady, and then if draw G buffer, else if draw illum buffer, else now we can write our shaders. We have 2 to write, and they're really not that long. 100 lines max. And most of it is actually copied directly from here. I'm going to copy that. Version 420 layout in Vec2. Don't forget that we have to read in the UVs. There's that. Then we got this. And then we have to read in our lighting textures. Well, first, we're going to read in shadow map. Albedo text. Specular. Or light accumulation. And then we ought to also remember to read in light space matrix and then because this is just a regular frame buffer, well, post effect, we only have 1 render target, so we just out vec4 frag color. And then, don't forget, we want to do our shadow calculation. We want the shadows in this shader. From here, we're going to copy this entire thing. This is our main. But we change a few things. First thing, albedo. First thing, we want to change that. Oh, vec4. Texture color. And then normals. And I named them the same as how they would have been. Regularly. We got to unpack them. And then we do, and in order to unpack them, we do the opposite of what we did before. We only need the one. .rgb. Do not forget to do these .rgbs, or else you'll get errors in your shader. Wait, sorry. Got ahead of myself. So we have diffuse here. We got our in normal already. We got our values. The light direction is sun. Down here, we don't have an in position. Well, in position is drag position. Then we have text spec right here. We don't have that texture. Instead, we just read our value in, calling it text spec. We got our texture color here. Don't have that. Instead, we just loaded in the albedo text up there. Bias, we want to change that. Sun dot bias. And then as for this, well, we do ambient power plus shadows, because shadows are never 100% 0. And then we actually don't want to use the texture color here. Whole point of an illumination buffer is it doesn't have the color of the textures. It has the colors, or it has the intensity of the light. So it should be mostly, white or whatever color your light is. And so here's what we're going to check. Remember I told you that background could cause issues? Well, that's the clear color. So if that object, if the background, if the texture color's alpha is less than 0.5, which we have set it up so that anything that doesn't get drawn on has a 0.3. You know what? We could set this to 0.31. 3.1 because of floating point errors, so odds are this that 0.3 becomes something like that. So we just do 3.1 just in case. So if it's less than 31%, we just output a white instead of, so 100% color. This way, our skybox doesn't get affected by our lighting, because that would be bad. Now, granted, this would mess with any transparency you have in your scene, and that is the trade-off. Deferred rendering does not do well with transparency. It does not like them. If you have transparents, I believe Tom talked about the solution, but that won't be showed in tutorial. That is something that you are going to have to figure out, basically. Typically, you do a deferred pass and then a forward rendering pass where you then render all of your transparents into your scene. Which is something you should be doing already with your transparents. But yeah, that is the gist. That's our directional frag. That is all done. Yeah, that's everything. Other than... Oh, that's right. So before we actually read in frag position light space, now we actually have to create it. So we just do vec4, and then we multiply the light space matrix by frag position. I knew I was forgetting something. And it just converts it. Yeah, that is the directional lighting. Now we just have to do the ambient. And then I want to go back over here. Copy this. And then we're going to we just want the albedo text. Sample 2D. Layout. Something equals 5. Oh, a skybox is what we call it. Out, vec4, frag color. I'm gonna try to capitalize that. And void main. I'm gonna change the name to ambient, because that's what it should be. Oh. There we go. Albedo. Light accumulation. And Firefox. And equals. So vec3, we add the ambient and light accumulation.rgb. This basically makes it so anywhere that was black on the light accumulation now is the color of the ambience. And we multiply in texture color to color the whole scene. And then add the skybox. Now, this actually has the added effect of coloring your ambient light, color of your skybox. I think it's pretty cool. It was sort of an unintended effect, but it looks good. Accumulation, and then, drag color, result. Now if we build, theoretically this should work first try. But we all know that theoretically things never go as intended. There's always a glitch. Some sort of error. Yep, see? Always. Line 24. Gbuffer directional frag. $72. Oh! Missed semicolon. Let's see what else went wrong. Issue with shaders is you always miss a semicolon or something. Oh, I forgot to flush main. Need to flush main so that it recopies the shaders. Interesting. Oh! Shader create. I got a index out of range error. It's always something. Oh! This is supposed to be ambience. Apologies. I'm sure there are a lot of people that caught those errors before I did, but that is the price you pay of recording a video. You are more focused on making sure you are getting information across than you are making sure that you don't miss a semicolon. And there we go. You can see still got directional lighting. It changes the direction. We've got it, goes up. And then if we press F1 while clicked into the scene, you can see all of this information. And notice that it's all white in the background, whereas this has our skybox. Press F2, and you will see the entire world is white. Even got specular highlights. At least you should. But specular's also. But yeah. That's pretty much it. And then if you press F2 again, I'll go back to regular. And yeah. That's all. Yeah, that is the end of today's tutorial. This should help you complete your second assignment. Please let me know if you find any bugs, obviously, as always. And I'll do my best to fix them in the repo. For the final finished push later on later. But yeah, this video will be uploaded immediately. And yeah. All right. Everyone have a wonderful day, and I will see you all on Friday. Bye-bye.